you. All right, you can find that video on YouTube. It's really amazing, and I would actually argue it is a movie. It's just a 3-minute movie. So, all right. So yeah, I'm Brian. I'm a technical engineering manager at Khan Academy on the content platform. Just kind of jump into it. What is Goliath? What is this rewrite that we did? It was a full, complete backend rewrite, for one. We moved from Python 2.7 to Go. We moved from monolith to services. We moved from REST to GraphQL, amongst many other things, including the front end. So in the front end, we went to edge caching with server-side rendering, GraphQL, all the things on the front end as well. And the web app is fully single-page application these days with more architectural parity with mobile. It was a big project. A few stats. It took 3.5 calendar years to complete, 40 person years worth of work, about 1 million lines of Python code, and about 1 million lines of Go code, over 3,000 Jira tickets, and over 100 engineers worked on it during that time. And we completed it 4 days before our contractual deadline. It's also a pun. Because we moved to Go, we chose Goliath. It seemed to work well. And it's a little bit funny too because Go's mascot is a gopher. And I tried to get AI to generate a David and Goliath scene with a gopher the size of a house. And this is the best thing I could get it to give me. Yeah. All right. So what went well? I would say our upfront planning went well. We defined 2 stages. One of them was called the minimal viable experience. We didn't call it an MVP because we already had a product. We were trying to look at it and say, what do we have today that makes us us? That's part of the MVE. And then we said the rest is going to be the second phase that we'll call endgame. We had to grind through every single REST endpoint, GraphQL, query, everything like that, and come up with task models for the work. It took a lot of grinding to make that work, but it paid off in many ways. We also socialized the project a ton. We had to remind people why we're doing this. We had a forcing function. Python 2.7 was end of life, and Python 3 was not backwards compatible. So we had to rewrite in something. And so we went to Python 2.7. We also wanted a more agile, maintainable code base and a less expensive code base. And so we finished and it didn't kill us. These types of projects are historically dangerous, and we did survive. I would not say unscathed, however. So for 3.5 years, product work stalled almost completely, at least for the first 2.5 years of that. We had some major hits to SEO because competitors were building features that outsearched ours, and they were building new features, and we were not. PM and design were really negatively affected. It's really hard to hear no. We can't build that for you. Month after month after month. And so we had a ton of attrition. Almost our entire PM and design team was different at the end of this project than in the beginning. We also lost engineers that didn't want to be a part or didn't want to spend a significant part of their career on a rewrite. It is worth noting that we did keep some engineers that wanted to see it to the end. But attrition was a real issue during that time. Well, let's talk about some good things again. Go was a great choice, actually, for us. It's easy to learn. It's one way of doing things was great. Strongly typed. We were looking for types. It had a reduced learning time, and so we increased doing. We had a huge cost savings on the back end because of it as well. We also had a pretty good architecture. We used Fastly as our edge caching system that then went to a GraphQL gateway that then aggregated off to all of our different services. This is a simplified diagram of what our architecture looked like. There were a lot more services and whatnot, but by using this GraphQL gateway, we were able to port not at the service level, not at the feature level, not even at the model level, but at the field level. We were porting things field by field. So you could have user.firstname in Python and user.lastname in Go, and the client wouldn't know the difference. And this enabled a really, really important part of the port that I would say is probably, I think, is the single technical thing that we did that cause us to succeed, and that's side-by-side testing. I want to dig into that a little bit. So the idea here is you've got a field in your GraphQL API, and it's in Python, right? That's the status quo. That's the way it's been. And then you want to start working on it in Go. So you have a Go-based service that implements this field, and you can deploy it. But all the traffic still goes to Python. If you want to test it, use a query parameter, and it goes to the Go service. Eventually, you get to a point where you think this thing is ready. You want to put it into prod, but you really want to be sure that it's right. And so the GraphQL gateway now sends it to both services. Uses the Python, sends that back to the user, compares it with the Go version, and then creates a report. And we can use that report to make sure that the millions of inputs cause the right millions of outputs. And once we're happy with that, we're able to move that over to the Go-based service. Python service still exists. In the code there still exists, but is only accessible through a query parameter. It's also really easy to roll back. Once we're confident that everything's great, no user regressions, delete the Python code, rinse and repeat for the thousands of fields you have in your API. Some things that didn't go so well, early adoption of GraphQL Federation Gateway required us to build some of our own frameworks. It turned out that we had a lot of performance issues with a node-based service, and we ended up writing our own federation server in Go. It solved our problems, but there were difficult problems to solve, and it slowed us down. A little bit about planning. You don't hear this very often, and I wouldn't say this about product work, but less agile, more waterfall. And Agile's really good for shifting requirements, variable scope, managing priorities, and it's good when you're building something new, but Goliath was fixed scope, fixed timeline, nothing new, and nothing to prioritize. We couldn't break what was already in prod. So instead, we used heuristics. We basically started with 50 lines per person today, 50 lines per person per day to start, and we mapped one point of work to one day, and then we followed the burn down. It was very waterfall in nature, a lot of upfront planning, but it worked. And so, I would say it was nearly impossible to start the project and say, this is how long it's going to take, because 50 lines per person today is an estimate. It's, you say it's 40, and all of a sudden you've increased months in your project. So you can see in the beginning there, we actually had to rework the models based on reality. And then we had a line that actually looked pretty realistic, and we stayed with it. The red line is the plan, and the blue line is reality. You can see there's a moment in the middle there where we kind of did a little extra prioritization, and it actually slowed us down for a bit because we had to move people to different teams, and it was new code and new ideas, and people had to stop what they were working on. But we caught up, and we ended up finishing it. And then I just want to talk a little bit about sticking the landing, because this was actually something that I don't think we were prepared for. But you get to the end of this effort, and you have multiple teams, and they have multiple tasks, and on paper it looks good. You can certainly finish the work in time, but it doesn't work because of the critical path. You have to really mind the critical path across all the teams and everything that's happening, because everybody is relying on everybody else for this to get finished on time. So, we had to dig through it, and we had to really just kind of line things up at the end and say, this is the deadline for the project, but for your team, this is your deadline. Or for this service, this is your deadline, and really find that critical path. And we knew that, of course, definition of critical path. If you miss it, you're going to probably miss your long-term deadline. And so what that really meant is that the product teams needed to finish first, and then the platform teams needed to finish next, so that the infrastructure could finish and get rid of all their stuff and delete their work. But in the end, we can celebrate. We finished 4 days before our contractual deadline, and it's been about 8 months since we finished this project, and it feels like distant history. Our new system has enabled us to move forward, and we are. A couple months after we finished this project, we delivered a GPT tutor called Conmigo on our system, and we were first to market with an education-based AI tutor. We're working on many more features already, and everybody is just happier with this new system. And it is cheaper to run, and we are more agile, and it was a success story. So we're really happy about that. That's really all I had. 3.5 years distilled into a 10-minute talk. I will be in the registration area. I'm not going anywhere after this conference, so I will be in the registration area after this if anyone wants to talk and ask me questions. So thank you. You're all beautiful. Thank you.